All right, guys. So we're finishing the note sheet from yesterday. So yesterday we started finding different ways to solve quadratics. Now, one of the first ways we went over with solving quadratics is by graphing, using the graphing calculator to graph it and see where it crossed the x-axis. We're trying to find the values of x that will make the equation equal 0, make the y value be 0 on a graph. The values of x that will make the function equal 0. And we went through that there. Then we went over the square root method. And I know we did this one here. I cannot remember if we did the 3x squared minus 9. I don't think so, but I cannot recall. We did this one? Okay. Now, our square root method had a few main steps. First step is to get the squared term by itself. And once we got the squared term by itself, we took the square root of both sides and add the plus or minus. And then our third step is to solve for the variable. So these here are our three main steps with solving square root, or solving by the square root method. Now, one of the main ways we know we can use the square root method is if we only have either x squared or the only variable that shows up in the equation is inside a set of parentheses being squared. So in this one here, since the only place that x, our variable, shows up is inside the parentheses here being squared, we can use the square root method. Now, if it told us that this here equals 5x, we have the variable inside the parentheses and outside, we can't just use the square root method. It does not work. Now, when we use the square root method, the first thing we're going to do is get the term being squared by itself. So we want to get this whole term, the x plus 3 squared. We want to get that singular term by itself. And we can do that by adding or subtracting any numbers outside the parentheses. Now, since there aren't any, we're not going to have to add or subtract. The only thing we're going to have to simplify is the 2/5. Now, because the 2/5 and our squared term are being multiplied, to simplify that, we're going to divide both sides by 2/5. Because our 2/5 divided by 2/5, anything divided by itself is 1, leaving us with x plus 3 squared. Now we're also going to have to divide the 5 by 2/5. So we can say 5 over 2/5. 5 divided by 2/5 is 25/2. Questions on this so far? Now, at this point here, we have the squared term by itself. There's nothing left being multiplied in front, and we have nothing added to it. So that means we can move on to step 2, and our second step is to square root both sides. And on the left-hand side, our square root and square would cancel, leaving us with x plus 3 is equal to plus or minus. Whenever we take square root of both sides, we have to add the plus or minus. Now we need to take square root of 25/2. Now we could do this by hand. We can calculate it out. Most likely you're going to want to plug it into the calculator. Now the 30xf and the graphing calculator won't let us just plug it in as the square root of 25/2. It's going to give it to us as a decimal. Even if we tell it to try to approximate, it's still going to give it to us as a decimal. So what we can do is break it up into its two parts, the square root of 25 over the square root of 2. And it'll tell us that this is going to simplify to 5 square roots of 2 over 2. Because what we're having to do is rationalizing the denominator to get this to simplify. All right. All right, guys, questions on this so far? So, at this point here, is the variable by itself? Well, no, we have the plus 3 with x. So the last thing we need to do is to get x by itself. We'll subtract 3 from both sides, leaving x by itself on the left-hand side. Now, whenever we add or subtract a number with the plus or minus, we're going to put this negative 3 in front of the plus or minus when we rewrite it back out, telling us that x is equal to negative 3 plus or minus 5 squared roots of 2 over 2. Now, if we can add or subtract these two terms, if they are both like terms, we need to add or subtract. Now, 5 squared roots of 2 over 2, because of that square root of 2, the negative 3 and the 5 squared roots of 2 over 2 are not like terms. We can't just add or subtract them nicely. It is possible to be able to add or subtract, because negative 3 plus 5 square roots of 2 over 2, we can add them, but it's not actually simplifying. It's just making them into one fractional expression, because these are not like terms. So this is as far as we're going to take it. Now, if they were like terms, we had negative 3 plus 5. We're going to add, we're going to subtract, we're going to combine those. If we can combine them, we're going to combine them. If we can't, we're going to leave it here. And at this point here, this is as far as we can take it. This is as simplified as it gets. Questions on this here? Let's look at our next one. It is 2/3 x squared plus 14 equals 20. Now, we can use the square root method because our only variable that we have is the x squared term. We don't have x to the first power. So we can use the square root method because we don't have that middle term. And the first step in the square root method is to get our squared term, in this case x squared, by itself. So the first thing we can do is subtract 14 from both sides. And that leaves us with 2/3 x squared is equal to 6. The x squared term is still not by itself, so we can divide both sides by 2/3. Now, our 2/3 x squared divided by 2/3, anything divided by itself is 1, leaving us with x squared. On the other side, we can do 6 divided by 2/3, giving us 9. At this point here, x squared is indeed by itself. So the next thing we can do is take the square root of both sides, and our square root of x squared is going to be x. Because again, we take square roots, we're trying to find out what times itself gives us x squared, and that is just x. On the right-hand side, we're taking square root of 9, so we're trying to find out what times itself is 9, and that would be 3. Square root of 9 is 3. Now that takes care of steps 1 and 2. Step 3 is we need to solve for the variable, solve for x. Well, x is indeed already by itself, so x is equal to plus or minus 3. And that's it. Questions on this here? Questions on anything we've done so far? Negative 2x squared plus 1 equals negative 6. Again, we can use the square root method because the only variable we have is the x squared. We do not have x to the first. So the first thing we'll want to do is get the x squared term by itself. So we can subtract 1 from both sides, telling us that negative 2x squared is equal to negative 7. Next thing we can do is divide both sides by negative 2, and our negative 2x squared divided by negative 2. Negative 2 divided by negative 2 will simplify to positive 1. So we have 1 times x squared, or just x squared. On the right-hand side, our 7 over 2, 7/2 does not simplify nicely, so we'll leave it as 7/2. However, the negative divided by that negative is going to give us a positive. Now we do finally have the x squared, our squared term by itself, which means we can take the square root of both sides. And our square root of x squared is going to be x. Now, since we did take the square root of both sides, we're going to put the plus or minus. Now, the last thing we need to do, or the next thing we need to do, is to simplify our square root of 7/2. Now, if we wanted to do this in a calculator, we do have to break it up into the square root of 7 over the square root of 2, because if we just leave it and try to take the square root of 7/2 and the 30 excess, it's going to give us this decimal. We want to try to leave it in simplest radical form, which will tell us that the square root of 7 over the square root of 2 is going to be the square root of 14/2. So the square root of 7/2 will reduce to the square root of 14 over 2. It's in simplest radical form now, giving us this here is the variable by itself. Yes. So we don't have to finish solving for the variable because it is already by itself, telling us that the solution for this one here is x equals plus or minus square roots of 14 over 2. Questions on this here? We'll look at this one as it is here, and we'll look at it again. We'll change it a bit and do it again. But if we look at this here, 2 times x minus 4 squared equals -5. So we can do the square root method on this here, because the only place the variable shows up is inside of our parentheses being squared. So the first thing we have to do is get these parentheses by themselves, this squared term by itself. And we can do that by dividing both sides by 2. So when we divide this here by 2, it gets us x minus 4 squared. The -5/2 divided by 2 is going to be -5/2. Now, since our term being squared is by itself, we can take the square root of both sides because our square root and square here will cancel, giving us x minus 4 is equal to. Now, we do need to simplify the square root of -5/2. Now, if we want to do this in a calculator, we can simplify it. We can break it apart to the square root of -5 over the square root of 2. Telling us that it is a domain error. And part of the issue that we're having, the reason it's saying domain error, is that we cannot take the square root of a negative number. There is no real number that when we find the square root, we find the number times itself that will give us a negative, which is telling us that there are no real solutions for this problem because we cannot take the square root of a negative, at least at this point here. We will be going over how to find the square root of a negative, how to actually get this number. And it's a non-real number because there is no number that times itself gives us a negative. And that's the issue. So really at this point, it's no real numbers because there is no number when multiplied by itself that gives us -5/2. Because if we looked at this here, I'm going to back up and graph this. Because to graph it, we would add 5 to both sides, telling us that we have 2 times x minus 4 squared plus 5 is equal to 0. Or squared plus 5. We get this function here. And as we see, it does not cross the x-axis. So if it doesn't cross the x-axis, there are no real solutions. There is no value of x, no real value of x. That will make this function be 0. That is why we get no real zeros at the moment. But we will be able to eventually solve this here and find the imaginary solutions or the complex solutions for this here. Questions on this here? All right, we're going to do a few more. So the last ones we're going to do are going to be solved by factoring, because we've done factoring already. I just want to do a few more so that we see them and we still feel comfortable with these here. Now, when we solve by factoring, first thing we need to do is make sure that the equation is equal to 0. We need to get the equation equal to 0. And for this problem here, x squared minus 4x equals 45. The first thing we can do in getting this equation equal to 0 is to subtract 45 from both sides. Now on the right-hand side, our 45 minus 45 will be 0. On the left-hand side, we're going to get x squared minus 4x minus 45. Now, after we get the equation equal to 0, we would see if there's a greatest common factor between the three terms. Fortunately, there is no greatest common factor between x squared, 4x, and 45. So we'll move on to our next step, which is our two sets of parentheses with 3 spaces. Next step in factoring is to find the sign. So we'll look at the sign of the third term. If the third term sign is positive, the signs are the same and match the sign of the middle term. If the third term is negative, our signs are opposite. Well, here, since the third term was negative, our signs are going to be opposite. One's going to be positive, and one is going to be negative. Now we're going to find the factors of the first and third term. So our factors of the first term, well, the only factors of x squared are going to be x and x. Then we need to find the factors of 45. Now there's a few factors for 45. We have 1 and 45, 3 and 15. 4 is not a factor of 45, but we have 5 and 9. So we have 1 and 45, 3 and 15, 5 and 9. Which one of these sets of factors do we want to try first? 5 and 9. Which one do you want to go with the plus? Which one with the minus? 5 and 9. Because once we get it set up, the last thing we want to do is check the middle term and make sure we have the correct factors. Now x times negative 9 would be negative 9x. Our 5 times x would be plus 5x. And negative 9x plus 5x is going to be negative 4x, which is indeed the middle term we wanted. So it tells us that these are the correct factors. Questions on how we got to this point here? Now the whole reason we factored was that to get this expression here, we have two things multiplied together to equal 0. And according to the zero product property, one of these two things has to be 0. Because the only way that I can multiply two or more things together and get 0 is if one of those expressions is 0. So we can set our x plus 5 equals 0 and x minus 9 equals 0 and solve for x. With x plus 5, we can subtract 5 from both sides, telling us that x is equal to negative 5. And that's it for that part there. Our x minus 9, we can add 9 to both sides because our negative 9 plus 9 is 0, giving us x by itself. And 0 plus 9 is 9. So that tells us for this here, the two values of x that make this function be 0 are negative 9, negative 5, and 9. Questions on this here? Are you ready for the next one? So here we have 3x squared minus 5x equals 2. So if we're factoring, if we're graphing most of our methods for solving, we're going to have to get this equation equal to 0. So we need to get everything on the same side. And to do that, we're going to subtract 2 from both sides. Since the 2 on the left side of the equation is positive, to move it to the other side to get it to become 0, we would subtract 2 from both sides. Now that we have everything on the same side, we can start factoring. We can look for a greatest common factor between these three terms. Now, since there's not a greatest common factor between 3x squared, 5x, and 2, we'll move on to our two sets of parentheses with 3 spaces. And once we get that set up, we're going to find the sign. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, our signs are opposite. So one's going to be positive and one's going to be negative. At this point here, we're going to find the factors of the first and third terms. So our factors of the first terms, the factors of 3x squared, well, x squared is going to be x and x. Our factors of 3 are going to be 3 and 1, or 1 and 3. At this point here, I would just plug the factors of 3 in one of the two spots, or 3 and 1 next to our x's. Our factors of 2, well, the only one set of factors of 2, and that's 1 and 2. So we'll plug those in and then check and make sure that these are the correct factors. If not, we can flip the factors of 2 and try again. Now 3x times negative 2, 3 times negative 2 is going to be negative 6x. Our 1 times x is going to give us plus x. Negative 6x plus x, negative 6 plus 1, going to give us negative 5x, which is the correct middle term. Telling us that these two here, 3x plus 1 and x minus 2, are the correct factors. They multiply together to give us our 3x squared minus 5x minus 2. Now the reason we factored them out into these two sets of parentheses is because of our zero product property, which tells us that if we have two or more things multiplied together to equal 0, one of these two expressions must be 0, either 3x plus 1 or x minus 2. And we can solve this here. Our 3x plus 1, the first thing we can do is subtract 1 from both sides, which will leave us with 3x equals negative 1. X is not by itself, so the next thing we have to do is divide both sides by 3. And our 3x divided by 3 is going to just be x. Negative 1 divided by 3 is going to be negative 1/3. And that's one of our two answers. Our x minus 2, we can add 2 to both sides, telling us x is equal to 2. So that tells us that negative 1/3 and 2 are the two values of x that are going to make this function be 0. Don't always have to have two unique solutions. We can have the same solution. We've seen that already. Any other questions on this here? We have two last problems. This one, let's see here. Yep, two more. This one and one more. Now this one looks to be a little bit different because it's not asking us to solve the equation. It's asking us to find the zeros. And what we've been doing up to this point is finding the values of x that make the function equal 0. And those values of x are called the zeros. So really what it's telling us to do is to figure out what values of x is going to make this function be 0. We call them the zeros, the solutions, the x-intercepts. They are all the same thing. So we're really solving for 2x squared minus 11x plus 12 equals 0. We're just trying to find out what value of x will make this be 0. Now, since it didn't specify how we solve it, we can solve it by any method. Really, the only methods that we have so far for solving are square root method, which doesn't work here because we have 11x, we have a middle term. We can graph it. So we could grab the graphing calculator, say y equals 2x squared minus 11x plus 12, and hit graph. And we do see that it does cross a point, one of the spots at a nice number, but it also intersects between 1 and 2. And if we look at the graph, we do see that one of the values of x that will make this function be 0, make the y value be 0, is 4. But there is another one, and we do have to find it. So we'll go on and graph this here. Factor this here. Not graph it, we already did graph it. So we're going to factor it. So the first thing we would find is the greatest common factor between these three terms. And unfortunately, there's not a greatest common factor. So we'll write our two sets of parentheses with 3 spaces. Now we're going to find the sign. Since the third term is negative or positive, our signs are the same. We're going to match the sign of the middle term. So it's negative and negative. At this point here, we want to find the factors of the first and third term. Well, 2x squared, the factors of x squared are going to be x and x. And the only factors of 2 are 2 and 1, so we can go on and plug those in. Now we also need to find the factors of 12. So the factors of 12 are 1 and 12, 2 and 6, 3 and 4. Now the first set of factors that we can try using for this here are 3 and 4. And we can check and make sure this works. 2x times negative 4, 2 times negative 4 is going to be negative 8x. Negative 3 times positive x is going to be negative 3x. Negative 8 minus 3, negative 8x minus 3x is going to be negative 11x. That is indeed the middle term that we wanted. So we were able to factor it. We were able to write it in such a way that we have two things multiplied together to equal 0, which is telling me that either 2x minus 3 is 0 or x minus 4 is 0 when we multiply these back together. And this is nice because it makes it a lot easier to solve. With our 2x minus 3, the first thing we can do in solving for x is going to be to add 3 to both sides. Because our negative 3 plus 3 is 0, leaving us with 2x. 0 plus 3 is 3. Still need to solve for the value of x, so we're going to divide both sides by 2, telling us x is 3 halves. Then for our x minus 4 equals 0, the first thing we can do, or next thing we can do, is add 4 to both sides, telling us x is equal to 4. And that's it. And we knew from graphing it that x was going to equal 4. We had to factor it to find the other term, and it does match up, and we can say, especially looking at the graph, that it does cross between 1 and 2, which is indeed the solution 1.5. It is there. Questions on this here? Are you ready for the next one? Can someone knock, or is that just... Okay. Last one we're going to look at is number 9. And again, if we're wanting to find the zeros of the function, we're just wanting to find the values of x that will make this function be 0. We're going to solve it by factoring first, and we'll also see how we would solve it by graphing. Because if we're going to solve this by factoring, first thing we're going to look at and see, is there a greatest common factor between x squared and 8x? And there actually is. What's in common between x squared and 8x? They both have what? They both have the variable x, because up to this point, the greatest common factor has only been a number. We can actually have a variable be a greatest common factor. And if we factor x out of x squared, if we remove one of the x's from x squared, we're left with x. If I remove x from negative 8x, all we're left with is negative 8. So we can have a variable as part of the greatest common factor. At this point here, we do have two things multiplied together to equal 0. Question? Focus up here. Thank you. Focus up here. Now we do have two things multiplied together to equal 0, so one of these two expressions has to equal 0. Either x is equal to 0 or x minus 8 is equal to 0. Now our x is equal to 0 is already solved. X is by itself. So the only thing we really have to solve is x minus 8. First thing we can do in solving this here is to add 8 to both sides. The negative 8 plus 8 will cancel, telling us x is equal to 8. So it tells us our two solutions for this here is x is equal to 0 and x is equal to 8. Now we could have also graphed this one here and said x squared minus 8x. And we graph it, we do see that it crosses the x-axis at 2 points. Second graph will tell us that the values of x are 0 and 8 because those values of x will give us a y value of 0. That's it.